2.1 or 2-1, which is slope-intercept form. So we're going to be given a line such as, or the equation of a line in slope-intercept form. In this case, we have 3x plus 2, and each of those numbers represents something. So the 2 is our y-intercept. So that's where the function crosses its, or the y-axis. The 3 is the slope. So first thing we'd have to do is just define slope. And so I'll write that here. So the slope is, one way to write it anyway, is to say it is the rise over run. So this slope in this problem, if I rewrite this equation, y equals 3x plus 2, you'll see there's no, it doesn't look like there's a run number. It looks like there's a rise of 3 and nothing under it. But every number is a fraction over 1. So in this case, the rise is 3 and the run is 1. So what I'm going to do is apply that to this graph. So I will graph the line 3x plus 2. So again, 2 is the y-intercept. So if I zoom here, this is my y-intercept. So that's at 2. And the rise over run is going to be, it's y over x. So we move in the up and down direction first, and then in the x direction. So from here, from this 2, we apply the slope of 3. So we'd go up 3 and over 1. So that would be a slope of 3. And we just follow that pattern. So from that y-intercept, if I just follow that pattern, I would go down 3 and over 1 for a point at negative 1, 1. And you'll see it's, if I connect those dots, I have a line. Okay, so that's the line 3x plus 2. Now, just to visualize the slope again, so this would be the slope triangle that I'm using, meaning you can measure the slope from a graph if you draw a triangle and say how far did it go up and over from wherever you started. But that is the way that you would graph the line y equals 3x plus 2. Okay, so I'm going to actually clean this problem up just a little bit. So I'm going to write it a little more vertically. Okay, so we're going to try this again. And in this case, you can see that the slope is different, but the 2, this is still your y-intercept. And the slope is a fraction, so this is still my slope. And just to be really clear, the slope, I'm going to actually draw this as a box. This is the slope. So the slope is, x is not part of this slope. The slope is simply the number in front of x. Okay, so if I go to my graph, so it's negative 3/4 x plus 2. I'm actually going to duplicate that and put it closer to my graph. You can see it. Okay. So if I want to graph this thing, let's use different color. Let's use green. So I'll start at the y-intercept as always. We can also call that the starting point or whatever, something like that. And so it's in the same place as the last one. And then we apply this slope of negative 3/4. So this negative sign here, you can apply it to the 3 or the 4, but you can't apply it to both. Because if you apply it to both, that would be a negative over a negative, which would end up being positive. But this slope is negative. So from this point, a negative slope is going to lie in the opposite direction of the last problem we did. So from this intercept of 2, I'll apply it to the 3. So I'll go down 3 instead of up 3. So down 3, and then I'm going to go right 4 um, in that case. So down 3 and right 4 gives me a point right here. Okay, so if you look at that little triangle that I drew in the last one, in this case, it's going to be something like that. And then we just connect these 2 points. I'm actually going to do that. My iPad doesn't like that. And so if I were drawing this on a piece of paper, I'd actually be drawing a line. Those 2 points. And that is the line y equals negative 3/4 x plus 2. Okay, so let's just do one more. This one is negative 2x plus 5. So again, this is my slope, or not my slope, this is my y-intercept, and this is my slope. So another thing we call slope is m. And yeah, I should probably back up and say this. Y equals mx plus b. This is your slope-intercept form without numbers applied. So m in this case is negative 2. And again, every number is a fraction over 1. Okay, so I'm going to graph negative 2x plus 5. So once again, I start on the y-axis at 5, because that's my y-intercept. And then I apply this slope of negative 2 over 1. And I'll make that 1 apparent. So I can apply that negative sign to the 2 or the 1 again, but not both. So in that case, I would go down 2 and to the right 1. So I'd get a point here. And I can apply that slope in any place, so I can apply it there too. So I'll go down 2 and over 1, put a point there. And if I draw that slope triangle, you'll see that there's one of them. There's another one. And that's going to happen every time you go down 2 and over 1. So then I'll just draw a line and place it there. Oh, that's pretty good. Just like that. So that would represent the slope, negative 2 over 1 with an intercept of 5. Okay, so next we're going to go to a slightly different problem. I am going to draw a line. Let's just see how we come up with here. So I am making this up on the spot, which I don't normally do, but I think we can make this work. Okay, so that is my line. Let's go backwards. Let's create the function from the, actually I'll make that a little more interesting. Okay, let's make the function from the graph or equation. So we're going to use this form, y equals mx plus b. So m is the slope, b is the y-intercept. So I'll write that out too. So again, this is the slope, and this is the y-intercept. Okay, so the y-intercept, we can see it is right there. So that is at negative 1. So this would be y equals something x minus 1. And the slope, if I draw one of those slope triangles between any two, these are called lattice points where the grid crosses itself. Let's draw a triangle. And I'm looking at this distance here. So that's a distance of 3. And this distance is a distance of 2. Okay, so the slope is going to have the numbers 3 over 2. There's always an x attached. And then you have to determine if the line is negative or positive. The slope is negative or positive. And from left to right, if you are going down like this, that is a negative slope. So this is actually negative 3 over 2x minus 1. Okay, I'm going to do another one of those. So let's draw another line. I'll just draw something like that, and I'll place it somewhere in the grid here. Okay, so let's take that one. Now let's create the equation again. So this one is y equals mx plus b. That's the form we want to use. And I'll put, the intercept point there. So the intercept on this one is -2. So I'm just filling in that space for b. And then we have to calculate the slope. So if you look at this line, it doesn't seem to cleanly cross any points except down here. I'm going to erase the arrow at this end so it's clear. It does cross right here on one of these points. So the slope on this one's going to be, sometimes your triangle that you're going to draw is going to be bigger depending on what the slope is. So I'm going to draw this little triangle. Okay, and now we just count the number of blocks between. So there's 1, 2, 3, 4, 5, 6, 7. So keep track of that. So it's 7. And then so that's the rise, and the run is 1, 2, 3. Okay, so that's just the equation, y equals 7/3 x minus 2. This function from left to right, you would go up, so that means it's a positive slope, so we don't have to add any signs to that. All right, so this is the next set. So given these points, write the equation of the line. So again, we're going to use this form of y equals mx plus b, and we'll do two examples, and I'll do each of them a different way. So for this one, this is what you do. So to find slope, so slope is m, we're simply going to subtract these numbers from one another. And this one, I know the numbers are 3, 0, and 0, 3. Just keep in mind that this is an x, and this is a y. And to differentiate those from 0, 3, I'm going to say this is x sub 1, x and y sub 1, and I'll do that same thing here. Except I'm going to use a 2. And all that is saying they're different. So these two y's are different. So here's one way to look at that. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And once you do that, you're just replacing the numbers. So we're going to go, well, y sub 2 is 3. We're talking about that 3. And y sub 1 is 0. So 3 minus 0 divided by x sub 2, so that's 0, minus x sub 1, which is 3. Okay, well, now this is a simple equation, right? So we could go, it's 3 over -3, so that's -1. Okay, so the slope is -1. And one of those things I can see from this point here from 0, 3, that's actually the y-intercept. So if I graph the point 0, 3, that means you start at 0. So let's zoom in here a little bit. Start at 0, and then I go up 3, and so that's my y-intercept. So for this one, since it gave us the y-intercept and I identified it, now I just have to apply the slope of -1. So I could jump to the equation of the line, but I'm actually going to graph this just to show you, another way to visualize it. So I will draw a line. Well, no, I'm not going to draw a line yet. I'm going to start here and I'm going to apply the slope of -1. And remember, that's really -1 over 1. So I go down 1, and then I go right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. So that gives me this line that looks like that. And that definitely has a negative slope. So that would be our line. Now, that's not what the question asked, but I'm just demonstrating a different way to graph. And so let's plug our numbers into our answer here. So you'd have y equals the slope value, which is -1. And I'll put the 1 there, but I don't have to. You attach your x, and then the y-intercept was the value of 3. So y equals negative x plus 3 is the equation of that line. Okay, so let's do that same thing here, and I will rewrite all of those um, designations. So this would be, it doesn't matter which one of these I say is 2 or 1, it just doesn't matter at all. So I'll say this is 2 just to show you it doesn't matter. Okay, so again, m is our slope. We're trying to come up with the line and y equals mx plus b. And so m is found by saying y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And then we just plug in those numbers. So y sub 2 is 5. Y sub 1 is 1. In the denominator, you have to be careful here because we have a negative number. So negative 1, it's good that it's in that spot actually. And then we subtract the number for x sub 1, which is 1. Okay, 5 minus 1 is 4. And negative 1 minus 1, you're going to go 1 below negative 1 then. So this is negative 2. So this is a slope value of negative 2. Okay, we don't have the y-intercept in this one, so let's see what happens when we try to create that. Hopefully it works. So that is the slope value. Oh yeah, no, this is, I have to do this one a little different. Okay, so then I have this equation. Let me set this up. Y equals negative 2x plus b. And so we don't have the intercept. So let's see what happens if I draw this line. So I know that it goes, actually I'm gonna do that in a second. So it goes to the point 1, 1 and negative 1, 5. Okay, so here's one way to do it. If I just connect those and I draw a good picture of that, I can see that the intercept is right here. So this would be a value of 3. So I'm gonna move that over and I'm gonna say, okay, draw this little arrow. Y equals negative 2x and with an intercept of 3. But what if you didn't draw the picture? That's the other part of this. So this is the answer. And there is a way to do this algebraically. So if I started here, y equals negative 2x plus b, then what I could do is solve for b. And I have these 2 points. I have 1, 1 and negative 1, 5. So if I just plug one of those in, and it doesn't matter which one, it'll give me the value of 3. So I will replace my y. I'm going to use, let's use this one up here. I'll use negative 1 and 5. So 5 is my y value. Negative 1 is my x value. And we do this. 5 equals negative 2 times negative 1 is positive 2 plus b. And then we subtract 2. So 3 equals b. So that's another way to get that y-intercept. And that's actually the preferred method to get it because they don't always cross evenly through our graph.